Bonjour and good morning. Welcome to WASA Distance Education and PLAR Math. And this is our last class in Term 1B. So this is week 9 of classes. Next week is our admin week. So no classes, but an opportunity for students to finish up what you're working on and write your culminating activity or your test. And then we're into Term 2A, which of course means that we're starting with the PLAR English in Term 2A. However, you students who do not finish in 1B can continue working into Term 2A. So don't stop working on your key questions just because the term is over. You carry on into Term 2A. Just continue working from wherever you left off and contact me if you have any questions as well. 2 ways to participate in classes via radio or Zoom, and the instructions are in your study guide, or you can contact your DEC or contact me for help with getting into the classes. All PLAR Math students are welcome to attend classes, so it doesn't matter if you signed up for Radio Zoom or if you signed up for IL, you're still welcome to attend the classes. They are for all PLAR Math students. To contact me, use email, phone, or send a message on Facebook, whatever is more convenient for you. PLAR English classes from last term and the PLAR Math classes from this term are available on YouTube and will continue to be available on YouTube. So if you want to watch those classes again, or even for the first time, they are available for you on YouTube. My YouTube channel is B. Osmond Wasa, and there you will find the PLAR Math and the PLAR English, the playlist for both classes. We also have the WASA Distance Education Center YouTube channel, which has all of the classes that we have offered so far this year available. So you can go there to watch all 4 of the PLAR English, all 4 of the PLAR subjects, or actually all 5 of the PLAR subjects, classes for the 5 subjects, and as well as the other PLAR courses, as the other WASA courses that were offered in Term 1A and Term 1B. Okay, just a reminder to students that this year students can choose to write the culminating activity instead of doing the lessons and key questions. So even if you have already done some of the key questions and submitted them, you can still opt to do the culminating activity. If you pass the culminating activity, then you get your credits. If you don't, and then you don't have to do the lessons or the key questions, and you just move on to the next subject. If, however, you're not successful with the culminating activity, then you will have to go through the lessons and complete the key questions before you can write the culminating activity again. So it's not a one-shot thing where you just get one chance to do the culminating activity. You do get more than one chance to be successful with the culminating activity. Next term is Term 2A, and this is the schedule for the Term 2A classes, as I mentioned earlier. For PLAR in Term 2A, it will be the English and the History Geography. The PLAR English will be Mondays and Wednesdays from 10 till 11, and the PLAR History Geography will be Tuesdays and Thursdays from 10 to 11. If you are doing the lessons, just a reminder that there are 2 types of questions in the lessons. There are support questions and key questions. The support questions are the practice questions that you do before you do the key questions. So as you go through the lesson, there will be information for you to read and then a support question. Do the support question and then go to the end of the lesson right before the key questions, where you will find the answers to the support questions. Check your answers against the answers that are in the back. If you are doing well with the support questions, then you move on to the key questions. And the key questions are the questions that you submit to me. They have marks. Okay? Do not send me the support questions. The answers at the end of the lesson. Do send me the key questions. Those are the ones that you get marked on. Okay, ways to submit your work. First way is to give it to your DEC, and your DEC will send it out to us here in Sioux Lookout. If your learning center is closed, or you don't have a learning center or a DEC, or your DEC is away, then you can submit your own work to us. Remember that if you are submitting your own work, be sure to write your name, the subject, and the teacher's name on your work. Definitely your name somewhere on the first page of your work that you're submitting, so that we know who's submitting the work and we know who we can return it to. So once you've done that, then you can scan, if you have access to a scanner, and email your work to studentwork@nnec.on.ca, and make sure you CC it to me. Or if you have access to a fax machine, you can fax it to our toll-free fax number. If that doesn't work for you, then you can use your smartphone to either take photos of your work or scan your work using the built-in scanner, and then you can email to that same email address, studentwork@nnec.on.ca, and CC it to me. Or if you want to, you can send it using Facebook Messenger. Okay. You can also, if you live in Sioux Lookout or the surrounding area and you come to Sioux Lookout fairly often, you can use our outdoor mailbox, which is located at the side of the building in the WASA parking lot. So just drop your work in there, or you can knock on the front door and give your work to whoever answers. You can also use Google Docs and send me the link to your work, and you can use Google Classroom. If you want to use Google Classroom, please contact me so that I can give you the link and the sign-in codes. Okay, just another reminder that at the end of term 1B, next week, we will have 2 student draws, one for students who earned a credit this term and one for students who submitted work this term. So for every lesson that you submit in term 1B, your name will be entered in a draw. So if you submit 5 lessons, then you get 5 chances to win a prize. If you submit 5 lessons and you do the culminating activity, then you get an opportunity. Your name will go into the draw into the credit draw as well, so you could win 2 prizes. Okay, and this is, as I mentioned, the last week of classes in term 1B. Okay. So that's it for the announcements. We'll start off with a review of our class on Tuesday, and then we're going to be finishing up lesson 5. So on Tuesday, we started lesson 5, and as I mentioned on Tuesday, we're looking at geometry. So lines, angles, we'll be looking at triangles and area today. So just as a review, first of all, a straight angle is basically a straight line. It measures 180 degrees. So angle ABC is a straight line. Sometimes what happens is we will have 2 angles that will create a straight line. So angle AB, and we'll say this is D up here, so angle ABD plus, so angle ABD plus angle DBC equals 180 degrees. Okay, because they create a straight line. So they're 2 angles together that make a straight line. So the measurements of those 2 angles will give us a total of 180 degrees. A right angle is half of a straight angle. So if you had a straight angle, if this was a straight angle and you cut it directly in half, you will have 2 right angles. A right angle measures 90 degrees. Okay, so angle DEF is a right angle. An acute angle is less than 90 degrees. So anything less than 90 degrees, from 1 degree up to 89 degrees, is called an acute angle. Okay, so less than 90 degrees. An obtuse angle is bigger than a right angle, but smaller than a straight angle. So it's going to be between 90 and 180. So it could be anywhere from 180 from 91 degrees to 179 degrees. So that's an obtuse angle. Okay, when two lines intersect, they create four angles. Two pairs of supplementary angles and two pairs of vertical angles. Supplementary angles add up to 180 degrees. So supplementary angles create a straight line. So angle A and angle D are supplementary angles. Angle A plus angle D will equal 180 degrees. On the other side, angle C and angle B are also supplementary angles. They will add up to 180 degrees. So we end up with four pairs of two pairs of supplementary angles. So angle A and B are supplementary, and C and D are supplementary. Okay. Vertical angles are opposite each other. Okay, and they are congruent, which means they have the same measurement. So in this diagram, angle A and angle C are opposite each other. So angle A equals angle C. Angles D and B are opposite each other. So angle D equals angle B. So they are equal angles. When two lines intersect, we know the measures. If we know the measures of one of the angles, we can calculate the measures of all the other angles. So in this example, we have two lines that are intersecting. We've got four angles. We've got angle D, which is 40 degrees. Okay. If we know that one angle, that measure of that one angle, we can figure out the measures of angles A, B, and C. For starters, angle B is opposite angle D, so that means that they are equal, so angle B is also 40 degrees. If angle A and angle D are on a straight line, those two angles create a straight line, so that means that angle A plus angle D equals 180 degrees. So to find the measurement of angle A, all we have to do is subtract the measurement of angle D, which is 40 degrees, from the measurement from 180 degrees. Sorry. Okay, so 180 take away 40 is 140 degrees. So that means that angle A is 140 degrees. And because angle A is opposite angle C is also 140 degrees. Okay, so we have only two measurements for four angles. Two angles measure 40 degrees and two measure 140 degrees. Okay, then we looked at angles created by parallel lines. So angles in parallel lines are angles that are created when two parallel lines, so here are your parallel lines, and we know they're parallel lines because they have these little arrows on them that show that they go on in the same direction, and they stay the same distance apart forever. And they are crossed by this other line, which is a transversal. So when that happens, we end up with four pairs of angles, so 8 angles. So 1, 2, 3, 4, 5, 6, 7, 8. And these angles have special relationships. So some of them are equal, some of them are supplementary. Equal or supplementary vertical angles. We have all of these relationships that are going on there. So we have alternate angles, and alternate angles are equal, and those are the angles that are inside the parallel lines, but they're on opposite sides of the transversal. Those angles are equal. And sometimes they're called Z angles because they can make the letter Z. They're inside the letter Z. We also have corresponding angles, and corresponding angles are also equal, and those are the angles that are on the same side of the transversal, but on alternate, on the alternate sides of the line, I guess you could say. So angle W, well, both those angles W are equal. And these are sometimes called F angles because they lie in the letter F. You can create an F with the letter lines. Then we have co-interior angles, and these angles are not equal, but they do add up to 180 degrees, so similar to supplementary angles. So these angles are interior angles, which means they're on the inside of the parallel lines and on the same side of the transversal. So G and H add up to 180 degrees. And sometimes they're called C angles because the lines make a C. The lines around the angles create a C, letter C. Okay, so, and then we looked at angles in a triangle. So the angles inside of a triangle add up to 180 degrees. So in this diagram, we've got angle A, angle B, and angle C. These are interior angles, and they equal 180 degrees when you add their measurements. We also have exterior angles. Okay, exterior angles are the angles that are created when you continue the line from the triangle, and they are on the outside of the triangle. So what you end up here having is because they are on a straight line, so angle C and this exterior angle, they make a straight line, they add up to 180 degrees. It's the same thing with all of those angles that are exterior. The exterior angle plus the interior angle equals 180 degrees. Okay, and then we looked at an isosceles triangle. An isosceles triangle has two sides that are the same length. Okay, and the two sides are the same length are the two sides that meet at the top, or they meet at a vertex. So the two angles that are opposite the equal sides are equal. So if this angle is, say, 40 degrees, then this angle is also 40 degrees. Okay, they are the angles that are at the base of the triangle. So again, opposite the equal sides and not where the two equal sides meet. Okay, so at the base of the triangle. So opposite that peak, the vertex angle. So you have to really look and see, especially if the triangle is on its side like this, you have to look and see where are my equal sides, where do they meet, and then it's the angles opposite that. Okay, so that's what we did on Tuesday in class. So today, we did straight angles and intersecting lines, parallel lines and angles in a triangle. So today we're going to finish up looking at more about triangles, the Pythagorean Theorem, and then the area of rectangles. So in your lesson, beginning on page 13 is some information about the Pythagorean Theorem. So page 13, 14, and 15, information on the Pythagorean Theorem, and then on page 16 and 17 we have your support question. So take your time doing that support question. Check your answers at the end of the lesson when you're done. Okay, so the Pythagorean Theorem. What is it? So a triangle that contains a right angle, so that's a right angled triangle, so it measures 90 degrees, and usually there's a small square in the corner that will indicate that it is a right angle. It's called a right triangle. So the longest side of the right triangle, and that's the side that's opposite the right angle, is called the hypotenuse. Okay? And the other two shorter sides, because the hypotenuse is the longest side, the other two shorter sides are called legs. Okay, so we can label them A, B, and C. So A and B are the legs, C is the hypotenuse. The Pythagorean theorem describes the relationship among the three sides of a right triangle. In any right triangle, the sum of the areas of the squares formed on the legs of the equal triangles, on the legs of the triangle equals the area of the squares formed on the hypotenuse. So what we're doing basically is side A plus side B equals side C. So A squared plus B squared equals C squared. That's our formula. So if we were to divide side A and B into little squares, equal units, then we added the squares in B plus the squares in C, we would end up with the squares in, squares for A plus the squares for B, we would end up with the same number of squares in side C. Holy smokes. So if we look at just squares that we created, that we've drawn on either side, and we've divided them up into equal units or equal little squares. So for side A, we've got 1, 2, 3, 4 times 4 is 16 units. And for B, we've got 1, 2, 3 times 1, 2, 3, which is 9 units. So 16 plus 9 equals 25. So if we look at side C, then we've got 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5, which is 25. So the area of the square on side A plus the area of the square on side B equals the area of the square on side C. So A squared plus B squared equals C squared. If you know the lengths of any two sides of a right triangle, you can always find the length of the third side with this theorem. For example, if the length of a leg, so A equals 3 feet, and the length of B equals 4 feet, then we can find the length of the hypotenuse, which is C, by substituting the values for A and B in the theorem. So just like solving an equation. So C squared equals A squared plus B squared. Same thing as A squared plus B squared equals C squared. Okay, you can write it C squared equals A squared plus B squared, whichever way you want. But remember, C is always the hypotenuse. So C squared equals, so we've got 3 feet, so 3 squared, remember we're talking about squares, plus 4 squared. 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. So C squared equals 25. So we still don't know what C is. We know what C squared is. Since 25 is 5 squared, this means that C is 5 feet. We can also find the value of C by taking the square root of 25. So C equals the square root of 25. C equals 5 feet. So C is 5 feet. Okay, so that's the Pythagorean theorem. So the Pythagorean theorem is used in many applications that involve right triangles. So for example, a sailmaker makes 2 sails by cutting a piece of sailcloth diagonally. So here is a piece of sailcloth. Here's your diagram. And he's cutting it diagonally to make 2 sails. If the width of the sailcloth is 5 meters and the diagonal, this part, is 13 meters, how many meters is the length? The theorem can be used to find the length of the cloth because the diagonal forms the hypotenuse. So 13 meters is your hypotenuse. So it's basically C. 5 meters is B, and A we don't know. So what we're going to do, same thing, we're going to use the same formula, A squared plus B squared equals C squared, and we're going to substitute in what we know. So we don't know A. We know that B is 5, so 5 squared. We know that C is 13, so 13 squared. So A squared plus 5 squared is 5 times 5, which is 25. 13 squared is 13 times 13, which is 169. So A squared plus 25 equals 169. To find A squared, we're going to basically solve an equation. Okay, so subtract B squared from C squared. So it's the same thing as going A squared plus 25 minus 25 equals 169 minus 25. We're subtracting 25 from both sides so that A can be by itself. So A squared is 144. Okay, so we're not done because we've got A squared. We need to find the square root. We need to find A. So now we're going to take the square root of 144 to find the value of A. So the square root of 144 is 12, because 12 times 12 is 144. The length of the sailcloth then is 12 meters. Now, you can find the square root of a number on your calculator. All you have to do is, on your calculator, punch in the number that you want to find the square root of, so 144, and then you hit the square root symbol. So it might look slightly different. So this is the one that's showing here. There's also one that looks like this, so square root with a bar. It might be the sign with a little line, or it might be just like that, so similar to this here for the square root symbol. But you don't hit equals, punch in the number and hit the square root sign, and you will find the square root of the number. Example 2. 2 cars leave town from the same parking lot. One car travels north for 8 miles, the other travels east for 6 miles. How far apart are the cars when they stop? So when you have them traveling, so the same spot that they're traveling from is the right angle. So one car travels north, straight north for 8 miles, the other one east for 6 miles. We want to know how far apart they are when they stop. So what we've done is we've drawn a right triangle. So we can use the Pythagorean Theorem to figure out the distance. And so the distance is the hypotenuse. We've got A and B. We need to find C. So we use our formula. In this case, we're putting D as the distance squared. Instead of using A, B, we can use any letters we want. Doesn't really matter. So D squared equals 6 squared plus 8 squared. So the distance in miles squared for each car. 6 times 6 is 36. 8 times 8 is 64. 36 plus 64 is 100. So D squared equals 100. Now we need to find D. So we need to find the square root of 100, which is 10, because 10 squared, 10 times 10, is 100. So the cars are 10 miles apart. Okay, so let's do a few examples. Find the length of the missing side in the following examples. Round answers to the nearest hundredth, so 2 decimal places. If necessary, show all of your work. So sometimes you won't need to round, sometimes you will. Okay, so here we've got, so if you're not sure where your hypotenuse is, look for that little square. So here's my right angle. Across from my right angle is my hypotenuse, or C. So either leg, it doesn't matter, can be A, the other one is B. So here we've got, write down your formula, A squared plus B squared equals C squared. So A squared is 6 squared plus B 3 squared equals C squared. So 6 squared is 6 times 6, which is 36, plus 3 squared is 3 times 3, which is 9. 36 plus 9 equals C squared. 36 plus 9 is 45. Equals C squared. Now I need to find C, not C squared. So the square root of 45 equals C. Now if I don't have a calculator, I can just leave it as the square root of 45 equals c. If I do have a calculator, I want to figure out what the square root of 45 is. So I'm going to punch into my calculator 45, and then I'm going to hit my square root symbol, and I end up with 6.7, a big long number, 0, 8, 2, 0, 3, 9, etc. So I'm going to say c equals 6.7. I'm going to round it to one decimal place. Or if I need to round it to 2, then it will be 6.71, because there's the 8 that makes it increase by 1. Okay. So round if you're asked to. If not, just you can round it to one decimal point or the nearest whole number. Okay, so number 2, again, if you're not sure which one is which, look for the square that indicates that it's a right angle and the hypotenuse is across from the right angle. So x is the hypotenuse. So again, I'm going to go x squared equals 7 squared plus 4 squared. I can keep my x, or I can change it to a, b, and c if I want to. 7 times 7 is 49, plus 4 times 4 is 16. So x squared equals 49 plus 16, which is 65. So x equals the square root of 65. So again, using my calculator, the square root of 65. So punch in 65, hit the square root symbol, and I end up with x equals 8 point, I'm going to round it to 0.6. The next number to the right of the 6 is a 2. Okay, so number 3, we've got our, let's not do number 3. Let's try to find, let's go do a different one. Whoops. Okay, so let's do number 4. So number 4, here's my right angle. Across from my right angle, this is my hypotenuse. My hypotenuse as a measurement in there. So what I'm missing this time is one of the legs. So if I do my formula, a squared plus b squared equals c squared. A squared, I'm going to say, is 3.7 squared plus b squared, I don't know, that's x, equals c squared, which is 4.2 squared. So now, I've got to use my calculator this time. So 3.7 squared is 3.7 times 3.7, which is 13.69 plus b squared equals 4.2 squared. So 4.2 times 4.2 is 17.64. Okay, so now I still don't know what my b squared is. This is like solving an equation. I want that b squared to be by itself. So 13.69 minus 13.69 plus b squared equals 17.64 minus 13.69. So now I'm left with b squared equals, and I've got 17.64 take away 13.69, which equals 3.95. So that's b squared. So b equals the square root of 3.95, which is b equals 1.99. Okay, so like I said, if you don't have a calculator, you can leave it as b equals the square root of the number. If you do have a calculator, find the square root using your calculator and round it. Now, and you don't have to have a fancy calculator. A regular calculator will do those calculations for you. It's a basic calculator. Okay, here's another one. This is a more practical one. You're locked out of your house and the only open window is on the second floor, 20 feet above the ground. So here's the second floor, and that second floor is, draw a line here, 20 feet tall. Okay. You need to borrow a ladder from one of your neighbors. There's a bush along the edge of the house, so you have to place the ladder 15 feet from the house. So your ladder has to go out here 15 feet. What length of ladder do you need to reach the window? So what length of ladder do you need to reach up to that window? So that's what you need to find out. How long does the ladder have to be? So this is your right angle. So this is side A, this is side B, this is side C. So you can use your formula. A squared plus B squared equals C squared. A squared is 20 squared plus B squared is 15 squared equals C squared. 20 squared is 400 plus 15 squared, 225 equals C squared. 400 plus 225 is 625 equals C squared. Now we need to find the square root of 625 equals C. So the square root of 625 is 25. So the ladder needs to be 25 feet in order for you to get into the window. Okay, so that brings us to key question 27. Find the unknown sides of the following triangles. And these are all right triangles. So here you've got here's your right angle, there's your hypotenuse, okay, or C. So A, B, C. The next one, there's your right angle, that's your hypotenuse. So this time you know what the hypotenuse is, you don't know what what B is. And then in C, here's your right angle, and you're finding the hypotenuse again. Take your time. Okay, so now that brings us to area of rectangles. So in your lesson on page 18, information on how to find the area of rectangles. Support question number 5 begins on the bottom of page 18 and on to page 19. Page 20 is information on how to find the area of composite rectangles. So page 19? Sorry, page 20. Then on page 21 continues on with support question 6 on the bottom of the page and on the next page. So area and perimeter. Before we get into area, just so that some people get mixed up in area and perimeter. So the difference between area and perimeter is that one measures the distance around. So if you think of a yard, perimeter is your fence that goes around the yard. Okay? Perimeter is your fence. Area is your actual yard. Okay? Your area is the space inside the fence or inside the yard. It's the ground. This is the area. So perimeter goes around. It's like your fence. Area is the ground that's inside the fence. So what is the area of a rectangle? Area can be defined as the amount of space covered by a flat surface of a particular shape. It's measured in terms of the number of square units. So we were just talking about squaring units when we were talking about the Pythagorean Theorem, so a squared plus b squared plus c squared. So same idea, square units. So square centimeters, square inches, square feet, whatever. The area of a rectangle is the number of unit squares, so little squares, that can fit into a rectangle. Some examples of rectangular shapes, so the flat surface of a laptop monitor, blackboards, painting canvases, the floor, a wall, those types of things. You can use the formula of the area of a rectangle to find the space occupied by these objects. So, for example, consider a rectangle, this rectangle right here, which is 4 inches long and 3 inches tall. So, if you were to put tiles, so if this is a floor, for example, it wouldn't be in inches, but if it was a floor, and we were putting square tiles on the floor, we would have 4 tiles long and 3 tiles high. So 4 inches by 3 inches. And we could count how many tiles it takes to cover the floor. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 12 squares to cover the floor, which means that the area is 12 square inches because we used squares. Okay, there is a formula that we can use to find the area of a rectangle instead of putting down square tiles. So, so the formula of the area of a rectangle is used to find the area occupied by the rectangle within its boundary, so within that shape. In the example that we just looked at, the area of the rectangle whose length is 4 inches and width is 3 inches is 12 square inches. So what we have is 4 times 3 equals 12. The area of the rectangle is obtained by multiplying the length and the width. So the formula is area equals length times width in square units. To find the area of a square, because with a square all of the sides are the same length, all we have to do is take the area and multiply a side by a side. We don't need to do all 4. If you're doing all 4, and you're adding all 4 together, you're getting the perimeter, not the area. So just take 2 sides and multiply them together. So in this example, we've got a square that's 7 meters by 7 meters. So 7 times 7, 49 square meters. Okay, so let's find the area of some rectangles. All right, so the first one, we've got a square. So side times side. So the area equals side times side. Our side is 60 meters, so 60 times 60 equals 3,600. So 3,600 square millimeters. Okay, that's a square. Let's look at a different one. Let's look at this number 5. We've got a rectangle here. So with our rectangle, the area to find the rectangle is area equals length times width. So our length is 75 feet, so 75 times our width is 55 feet. Excuse me. So our area is 75 times 55, which is 4,125 square feet. So remember to put in that little exponent of 2 because that shows that it's square feet. Okay, number 6, we've got a rectangle again. We've got a width and a length. So our area equals length times width. Our length is 87 times our width is 49. So 87 times 49 is 392 square inches. Again, don't forget that little exponent of 2. Okay, so just length times width. Okay, so for the area of composite shapes or compound shapes, what we end up with for a compound shape is a shape that's made up of more than one rectangle. So if you need to find the area of a compound shape, then what do? You break it into pieces. So you separate the rectangles. So separate the rectangles into basic shapes, so 2 rectangles. So you can do it by drawing a line, horizontal line, and then you have one rectangle on top of the other. Or you can draw a vertical line and you have one rectangle beside the other, whichever way you want to do it, whichever way makes most sense to you. And then once you find the area of each rectangle separately, you add them together. Okay, so here we have a rectangle It has all of its measurements in there. So this top line is 9 feet. This small one is 2 feet. This one is 5 feet. Then we have 4 feet, 4 feet here, and 6 feet up the side. So all of the measurements are there. Sometimes you might not have all of the measurements and you might have to figure out a missing measurement. We'll look at an example of that in a few minutes. So the first thing you want to do is draw a line to break the compound shape into basic shapes. So here I've drawn a horizontal line so that there's one rectangle on top of the other rectangle. That's one way to do it. You can also do it so that you have the orange rectangle and the green rectangle. So it doesn't matter, whichever way works best for you. So then what we're going to do is we're going to find the area of each rectangle by multiplying length times width. So this is our first rectangle and this is our second rectangle. So rectangle A, our length is 9 feet. Our width is 2 feet, so 2 times 9 is 18. So the area of rectangle A is 18 square feet. Rectangle B, we've got 4 feet because it only goes up that far. It doesn't go all the way up, so it's not this measurement, 6 feet, because that goes all the way to the top, by 4 feet across the bottom. So 4 times 4 is 16. So rectangle B is 16 square feet. So I've got my two rectangles. A, as I said, is 18 square feet. Excuse me, B is 16 square feet. So now I'm going to add the areas of the basic shapes together. 18 plus 16 is 34. So the area of the compound shape is 34 square feet. Okay, find the area of each shape. Okay, so here we've got two rectangles put together. So we've got 7 feet across the bottom, 30 feet up the side, 20 feet up this side, 25 across the top. But we've got two sides here. We don't know what the measurements are. We need to find out those measurements. So to find out this measurement here on the right hand side, what we need to do is look at the length of the side from top to bottom, which is 30 feet. So 30, and I'm going to subtract this length, 20 feet, which only goes up as far as here, because this is the side, this is the part that I want to find right here. So I'm going to subtract 20 feet. So 30 take away 20 equals 10. So that means that this side is 10 feet. Okay, to find the length of this side, I'm going to take the length of the top, which is 25 feet, and I'm going to subtract this piece here, which is missing, and that's 7 feet. So 25 take away 7 is 18 feet. Okay, so that means that this side here is 18 feet. So now I have all my measurements. So now I can find my area. So I'm going to divide my rectangles this way. So I have 25 feet times 10 feet. 25 times 10 is 250. And then my second rectangle, so this is rectangle A. Rectangle B, I've got up as far as there. So 20 feet times 7 feet is 140 feet, or square feet, I should say. Okay, and now to find the total area, I need to add them together. So I've got 250 plus 140 equals 390 square feet. That's the area of that rectangle. Okay, so same thing with other ones. Let's look at this one over here. So number 3. So we've got 7 inches, 4 inches, 5 inches, 9 inches. I need to find the measurement of this side and this side because they're missing. Okay, so to find the measurement of the side on the right first, I'm going to take the side of the left, the measurement of the left side, which is 9 inches, and I'm going to subtract this part on the right, which is 5 inches, and that will give me 4. So this side is 4 inches. To find the bottom, I'm going to take the distance across the top, which is 7, and subtract this part, which is 4, which will leave me with 3. So this is 3 inches. So now I have all of my measurements. So now all I have to do is separate the rectangles and multiply. So I'm going to draw a line. This time I'm going to draw my line, a vertical line. So this is rectangle A, this is rectangle B. So rectangle A is 9 inches by 3 inches, so 9 times 3, which is 27 square inches. B is 4 times 4, 4, which is 16 square inches. So now my area is 27 plus 16, which is 43 square inches. Okay, so that's how you do that. Okay, so that's key question 28. Find the area of the following shapes. So you've got A, which is a basic rectangle, B, which is a square. All sides are equal, but remember, to find the area of a square, all you need is one side times another side, not all 4 sides. And then C is a composite rectangle. So for C, you need to divide. You need to find the missing lengths first, which is the length across the top and this one up here on the side, and then separate your rectangles and multiply. Okay, and that is it for lesson 5. So that's it for PLAR Math in term 1B. So finish up your key questions and send them out to me for marking. If you want to write the culminating activity, please contact me. Other than that, I will talk to you again in term 2A, which begins February 3rd, I believe. So good luck with the key questions and the culminatings, and enjoy the rest of your week. Miigwech.